G'day traders, Rich here. This particular video follows on from the prior video we released, which was part 1 of an instructional video series. This video, which is part 2, looks at the optimization process. As discussed in our podcast number 8, where we overviewed the entire process, we adopt a workflow process that is categorized into 3 sections. The first being optimization, the second being iteration, and the third being the actual trading and testing of the suite of strategies. So in this first stage process optimization, this follows after we have designed the broad variables of our strategy that we now want to test and ensure that they are robust amongst a broad array of different market conditions. So for this particular Donchian trader, we're now entering the optimization process. So the first thing we do from our expert advisors is select the optimizer, which is one of our 3 different programs we use for portfolio compilation. So we'll select optimizer, and now that allows us to undertake the optimization process. The next step is to select a market. In this instance, we'll take Euro USD as our example. We use open prices only for our testing purposes, as the strategies are designed using open prices only, so there is no material variation between tick data testing and our open prices method. So for speed of processing, we use the open prices method. For our date range, we tend to assign approximately half of our available data to our testing process, leaving the balance of our data for out-of-sample testing. So in this particular instance, I'm going to be using a range of between 2000, the 1st of the 1st 2000, up to 2019, and the 31st of the 12th. Now, just to explain this, we have data for out-of-sample testing that goes back from this date back to around about 1986. Now, the reason we're using the front end of our data for our in-sample testing for this process is that we want to ensure that our optimization process looks at the market conditions over the last 20 years. So there is a greater chance that our optimized strategies will be at least configured to respond to the more recent market conditions. What we have found is that for robustness purposes and to avoid curve fitting, we must use a large in-sample testing period as well as a large out-of-sample testing period. For instance, if we were testing only over a 1 to 3 year period, we would find that the optimization would configure our results to respond to the most recent market condition. Because we're using the last 20 years of data, that is looking at the market conditions that have been presented to us over the last 20 years. And so there is more chance when we use these risk-adjusted metrics in our determination of selection that we have chosen the more robust value sets that respond to a broader array of different market conditions. So in general, the larger the data sample you use for your in-sample testing, the less chance there is of having a specific curve fit response. Not only because of the fact there is a greater data series to avoid the impacts of a random generation of results that have no logistic foundation against the markets they're trading, but also because we ensure that using a broader range of different market conditions, we aren't therefore encouraging our optimizer to only respond to a narrow set of market conditions. So now that we have explained the date selection, so in this case from the year 2000 up to the end of 2019, because we're doing the optimization process, we aren't undertaking a visualization, so we turn this off and we move over here to the period, which we select as daily. The spread. In determining the spread to use for our testing purposes, refer to the current spread of the market for Euro USD, which is 11 points. So in this instance, let's use double the spread, so that therefore it integrates a degree of slippage into our assumptions. So we'll use 22. Now then, what we do is we make sure that the optimization box is ticked as we're undertaking the optimization process, and now we move on to the expert properties. So when we select the expert properties, we move to the testing tab. We select 100,000 for our deposit for our optimization testing in US dollars. We also make sure that the genetic algorithm box is turned off, as we want our optimization process to iterate through the entire possible sequence of optimization values, as opposed to selecting a narrower range based on using a genetic algorithm. So we turn that off. When we go to the inputs tab, the first thing we want to do is we want to load our optimization set file that we've already incorporated into our download pack. So we select load. We now refer to the tester menu of the MQL directory, and you'll see the set file called DON optimization set. We select that by clicking open, and this will therefore use the common optimization ranges that we are currently applying for our testing purposes. So we'll now step through this. In the password section, you need to apply the password that is available to you and supplied on our forum. This will ensure that the backtest module works. If you don't apply a password, you can't use this algorithm in either the backtest or the demo or live mode. We also refer to the dollar amount of risk per trade. Because we're using 100,000 as our initial deposit, we'll apply a $500 trade risk to every trade that we apply, which is therefore basically a 0.5% trade risk per trade based on our initial deposit. But in this case, so $500. For the Donchian period, we notice that we are going to be testing a range of between a 50 Donchian lookback to a 600 Donchian lookback with steps of 50. Now, in relation to the use of steps, what we want to avoid is using two smaller step increments. The reason we do this is that we want to avoid a curve fit response. Perry Kaufman actually has a very good podcast on, I believe it's Better Systems Trader, which looks at different methods of using optimization. In his recommendation, he is suggesting that a logarithmic scaling factor should be applied for your step increments. For instance, the difference between 50 and 100 being 100% is the same as the difference between a lookback of 100 to 200, or 200 to 400, or 400 to 800. That's using a logarithmic scaled process of incrementation. Now, we'd like to use that, but for simplicity purposes, we're just ensuring that we're using very broad steps of 50 increments. We don't want to start applying steps of 5 increments or 10 increments. We want to ensure they're broad, because the outcome of this process, we want to ensure A, it's not curve fit, and B, we're using a broad suite of strategies that comprehensively address a broad range of different trend types when we are targeting this system as a trend trader using a variety of different strategies. So we then move to our ATR period. For this particular test, we are using a range of between a 10 bar look back for our ATR determination to a 40 bar look back for our ATR determination with step intervals of 10. For our initial stop loss we apply on every trade we undertake, we are using a range of between 2 ATR to 10 ATR with a step range of 1. For our trailing stop, we are looking for a range of between 2 to 25 with a step value of 1. For our break-even condition, this isn't essential to the program, but we are using a test range of between 2 and 6 with a step of 1. We are not selecting record all trade history, as that will therefore generate a very large file of all of the trades undertaken for our optimization run, and this will hang your PC if you use this for the optimization process. So make sure this is set to false during this optimization process. So if we move to the optimization tab, there's nothing to address on this particular tab, and so we've now set up all of the values and the step intervals that we wish to use for our optimization process. And now we select OK to close that screen, and we are now ready to run the optimization process. So now we hit the start button and the optimization will commence. When we go to our optimization graph tab, we'll note that we have some optimizations already undertaken. Each black dot in this particular display shows one iteration. So this is going to be a lengthy process and is very dependent on the resources or processing capacity of your PC. If we go back to the settings tab, we'll note that there is a total possible number of 51,840 iterations that are going to be tested based on the parameters and the values that we set for those parameters within our optimization run, and at the moment we're only up to the 22nd run of 51,000, so this is a time-consuming process. Now I'm working on a very slow PC here. I actually have a much more powerful PC that I run this process on, and for a process such as this involving 51,000 iterations on my more powerful PC, it might take between 5 and 6 hours to run one optimization run. In this instance, over on the right hand side, it's telling us that on this very slow PC it's going to take us 291 hours to undertake this run. Well, I'm hoping that the people that use this will have more powerful PCs than the one I'm using for this presentation. So now while this is occurring, this optimization process, in the background there are files being generated, and we'll refer to those files now. So if you go to File and Open Data Folder, and you go to the tester subdirectory, you will see a subdirectory called Files. Double click on that and we come to our Donkian subdirectory. This is where all of the results of our Donkian testing processes get stored. When we open that subdirectory, we see that 3 files are currently being generated. We have got an equity file which records on a monthly basis the unrealized equity of each of the iterations currently undergoing with the optimization run. It has a performance file which details the performance of each particular iteration which we use for our portfolio compilation process, and it includes a file called return which offers on a monthly basis the return outcomes of each particular iteration. And as this optimization process is being undertaken, you can see that these files are slowly growing in size. So what I'll do now is I'm going to pause here and I'm going to come to a completed file of this process, which is the results of what you get after this long wait of many hours of optimization. So here we are, about 6 hours later, the optimization process has been completed, and we'll see that the size of these files are quite large. The equity file here is around about 853 megabytes. So it's a large file. We have the performance file which is around 7 megabytes, and the return file. So let's now have a look at what's contained in each of these files. So we'll open up the equity file and I'll just show you what we have. So what this records is the first column relates to the magic number applied to the individual iteration. So in this case we can see for this particular iteration for magic number 5300201, we have a monthly date series going from 2000 right up to current, up to 2019 for that particular magic number. And we have the monthly equity in column D, which starts at 0 and then up or down based on the equity performance on a monthly basis. Now this is using the floating equity calculation. Column C is the actual market price of that instrument, so in this case Euro USD. We record this for map to market analysis, which we use in a later function that we'll be describing in one of our future videos. So that's the equity file, which is very large indeed, recording every single iteration on a month-by-month basis over a 20-year period. When we look at our next file, which is our performance file, we can see that each particular iteration is consolidated into a single run. So this particular iteration for magic number 5300201, a particular iteration, we can see that we have details of the settings used for that iteration. So when I go to column U, I see that we have a Donchian period, in this case 200. The ATR period used for this iteration was a 10 ATR period. Stop loss multiplier was using 2 ATRs for our stop loss. Trailing stop multiplier was using a 2 ATR trailing stop, and our break-even multiplier was moving to break-even at 2 ATR. And we have the performance results from column E up to column T, which detail the total net profit, the number of trades, the dollar risk assigned for this particular iteration, which is 500, the compound annual growth rate, the maximum drawdown experienced over this run in both percentage and dollar terms. So this is percentage and this is dollar terms. The MAR ratio, which is the relationship between the compound annual growth rate and the maximum drawdown in percentage terms. The total gross profit, the spread in cost assigned to this particular iteration, the swap, the commission and the total cost structure. The probability of a win, the average win and the average loss, and the skew of the series. So as you can see, this performance file is also very large, and this will give the performance details of all of the entire 40,000 iterations that have been performed for this particular strategy. So that's the performance file. And the last file produced is the return file, which, like the equity file, records the magic number of each return series and the total return achieved by the individual return series. Now, these three files you don't have to worry about. These are actually used for our iteration process, which automatically looks to these files to then conduct iterations. So this is more the files that are generated that are needed for the second stage of automated processing. So that's it in a nutshell for this optimization series. I think we can leave it there, and our next video will be discussing the next stage of the workflow process, which is the iteration process. So we hope you enjoyed this video, and stay tuned for future videos, instructional videos on this process. Thanks for watching.